Hey everyone, and welcome to Vector Space Talk. Today I am joined by my wonderful colleague Jenny and Trey, as well as Doug, and they're going to be talking to us about AI-powered search. Hey Jenny, how you doing today?
I'm doing a little bit sad actually, because today my research in search hit a little bit like our limits. So I'm actually glad that we have a way to ask a lot of questions today from the people who are very experienced with search, because that's going to probably motivate me to start once again. So please, guys, I would like to use it as a segue to introduction of how long we are working with search and like a little bit about your roles in search.
Yeah, why don't we start with Trey?
Awesome. Thank you guys for having us. I'm Trey Grainger. I am the founder of a company called Search Kernel, author with Doug and also Max Irwin on the book AI-Powered Search, which we'll talk about, I'm sure, some today.
Sure.
And yeah, experience in search. I've been working in search most of my career since about 2007, 2008. A software engineer, kind of built out a search team at Career Builder. Kind of moved my way up there, had a large search team, went to become head of engineering at LucidWorks, and their chief algorithms officer, was the CTO at a decentralized web search engine. And now I run my own company, Search Kernel, doing AI-powered search consulting and building cool stuff, which I'm sure we'll talk some about today. But I've been doing search for a really long time.
Very cool. And how about yourself, Doug?
Yeah, so I've done search probably around the same amount of years as Trey has, but back in the 2010s, I kind of got into search accidentally because, especially search relevance, because everyone was building back then Solr and Elasticsearch applications when those were kind of coming on the scene and new. And then, of course, everyone builds these beautiful UIs and then they realize the results aren't any good. So I became the fixer. And that eventually transitioned to being more strategic about thinking about search and relevance at organizations. And I've just been on an adventure. I got to write relevant search back in 2016. AI-powered search with Trey helped build some learning to rank functionality for different search engines, like classic search engines like Elasticsearch and OpenSearch. And lately, I spend a lot of time with AI startups trying to help them with their search. Most recently, Daydream, a big fashion AI startup, after having worked at Reddit and Shopify on their search. So I've kind of been all over the place, done a lot of cool stuff. And lately, my passion is like, there's a lot of abstract ideas in academia, and I get excited about how things actually work in practice and companies in a real engineering organization now that I've gotten to do that at a couple of places now.
Very cool, very cool. And one common thread I heard from both of you is that you've been working in search before the rise of LLMs. And I'm just kind of curious, before we dive into the book, how has search changed from when you started working in search to the situation that we have today?
Oh man, do you want to take that first, Doug?
Yeah, I mean, obviously vector databases are like, in some ways, hitting the reset button on search and taking a perspective of search from a completely different angle that really complements traditional search engines. So vector databases, obviously, I mean, I probably don't need to tell your audience, but like just the concept of an embedding that can embed something, obviously language, but really anything, so that almost like with encoding the knowledge of the world about that thing in such a way that similar things are close to it and dissimilar things are far apart is just game changing. Whereas before, we sort of had to use a lot of expert knowledge and things, and this is still actually the case in a lot of cases, but use a lot of expert knowledge to sort of like know, like, oh, these fashion items are similar, or these legal concepts are similar, and we need to map them into a knowledge graph, and someone has to manage that. So I think there are like complementary approaches, but obviously it's just become so ubiquitous to pull down embeddings from Hugging Face and build something really quickly that often it's the first place people come into and discover information retrieval and search engines.
Yeah, it's definitely interesting to see like the very first time you do something on a vector database and you have that, like, especially with the images, and it just works and you're just like, wait a second, is this magic? Like, what's going on here? So it's definitely a weird feeling. Trey, how about yourself?
Yeah, so there's a lot of techniques. I'm going to say most of the people I encounter working in search tend to come from one of the two camps, right? Either the sort of traditional inverted index. I don't like to call it lexical because it's a lot more than just, token matching. There's all sorts of fields and data types and what have you. But, the lexical side. And then, more recently, a lot of people are coming from the embedding side and sort of getting into search because they realize they need RAG and they realize that the RAG's not very good. And then they sort of work their way into getting better at it. And so the two worlds meet in the middle, obviously, where you've got combination of dense and sparse vectors and everything. But what I find is that there's a lot of techniques that on the lexical side of things, on the inverted index side of things, we sort of learned over time how to do things in a very manual way. And on the vector side, I see people sort of starting with out of the box embeddings and getting something magic, working out of the box, but then being stuck and not knowing where to go. And so what I spend a lot of my time doing is actually helping people like on either side, whether they're coming from the getting started with embeddings or coming from the inverted index, and try to push everybody to the middle where there's this shared space of techniques that actually are interoperable. They work well together and are very complementary, but most people don't have that full perspective. And I feel lucky to have been in search so long and to have learned most of the sort of inverted index side of things in terms of techniques, but also my interest is most of my career been in relevance like Doug, data science and machine learning and applying machine learning to the data you're using for search. So I think folks like Doug and I have this sort of unique ability to kind of stand in the middle and see both sides and bring them together a bit.
Yeah, sometimes it almost feels like the classic, like if you pick a sock out of a drawer example, except now you can actually see in the drawer. You're not just randomly looking or like trying to remember where you put it. It's nice to have that explainability. Oh, Jenny, let's try to see if we can help you debug your research project. Do you have anything for Doug or Trey?
No, actually, firstly, I want to ask a question which is related to what you both mentioned. And you both said that a lot of tools said that you were seeing for a long time in search, like in lexical, are actually applicable in the embeddings world, in the vector search world, and they're making everything, well, much better, much relevant. But the people, for some reason, coming from the camp of vector search, start from scratch. I don't know why it's always like this, but people start from scratch. They're like, hell yeah, this is going to solve my search. And they throw away all the experience of the previous years, and they're like, yes, baby. And then well, they're rediscovering everything from the start. So maybe we can help them a little bit, and you could actually advise already some tool sets that are applicable from the start in the embedding world, and they are already time proven in the lexical world. And that actually connects to my current research. So at some point I will use this opportunity to debug it.
Yeah, and I kind of view it as everybody has a starting point. It used to be, let's go to the inverted index approach. Somebody would spin up Solr, Elasticsearch, one of those variants, index some data, a couple lines of code to put your data in a schema, push it in, and then you start to search, and out of the box with BM25 matching, it's just kind of magic. Like all of a sudden, your matching documents are coming back, they're ranked, and you're getting features and the ability to do analytics, or, faceting. You get all these features, and it's like very eye-opening the first time you do that. And then you do a project, you impress a bunch of people internally, you build the product, you ship it. And then as soon as it gets to production, you start getting feedback from your clients, from your customers. And they're like, well, hey, this query doesn't work, and this query doesn't work, and this looks bad. And then you start down this journey of, it's not as great as I thought. There's a lot more work to do to make it good. And you start the process of slowly really understanding the data, understanding the business, understanding the use cases, and that's a never-ending journey of improvement. So that's the old way of doing it. The new way of doing it is, I've got a bunch of data, let me pass it to a transformer and get embeddings out and put them in the engine, and then you send some queries in, and it's magic. All of a sudden you're matching and you're ranking, you're seeing things at the top. And it's not just understanding keywords, it's understanding the meaning of what was typed in and the meaning of the words. And so it feels like magic. So you impress a bunch of people internally, you build it, you release it to customers, and then all of a sudden it gets in front of them and they're like, hey, this query isn't great, and this query isn't great. And you start down the same journey, but you're coming from two different perspectives. So the real issue is, in my view, out of the box, what works in both cases is magic. It feels like magic. But it only goes so far. You can only, cast that first magic spell until you have to actually, learn how to really do magic. And that's when you start to get into relevance tuning and ranking and better models, and how to combine different features together, whether it's lexical based, embedding based. It might be knowledge graph based. It might be leveraging user behavioral signals to try to learn what users actually want to boost certain signals or to personalize. There's all these different directions you can go, but none of that works out of the box. And so then you have to begin this journey of really doing the hard work. And so for me, I see that as why people are reinventing the wheel. It's not that they want to reinvent the wheel. It's that they were given a little teeny tiny wheel and they need a better wheel, and they just don't know what they don't know.
Yeah, it's actually all boils down to relevance. And I don't know, the thing is, it's like with figuring out something like our brain. I don't know, relevance is too complicated to formulate, right? So in the end, it's either very use case specific or it's generic. I don't even know how to formulate it. Maybe you are actually closer than I am on formulating what its relevance. Could you maybe explain to us, both from your experience of all of these years, what is relevance? Can it be generalized? And did it become harder to define relevance in this semantic similarity embeddings concept that we're facing now in search?
Yeah, I'll start with a kind of mental model that we use in the book. So the goal, whether it's vector search and you're doing RAG or traditional search or lexical, whatever, to me, the goal of search and relevance is to understand the user's intent and to bring them back an answer matching their intent. They might be looking for a document. They might be looking for an answer. They might be looking to take some action. They might be looking for some code to be generated for them. But whatever they're putting in is either a prompt or a query. They have some goal, and the job of the system is to understand that goal and to return them back the best thing that it can that matches that. So in the context of search, I typically break things down into three contexts. There's sort of the content context, which is, what documents do you have? What data are you putting into the search engine? There's the domain context, which is, what is your business? Is it e-com focused on tech? Is it, a bookstore? Is it enterprise search focused on an accounting company? But that's the domain, and that's where your terminology comes from and the use cases and all of that. And then there's the user context. And the user context is, who is the person that is coming in and running the search trying to get this answer? And if you think of those as concentric circles, if all you're focused on is the content context, then that's basically your typical search engine. Whether it's a vector database or whether it's an inverted index, you're just putting data in and you're matching on, terms that are in there, and then you're returning back. If you only focus on the content context, if you only focus on the domain context, well, that's basically a knowledge graph. You've got this modeling of the domain and what it means, but it's not attached to necessarily your content, and it has no understanding of your users per se. And if you only focus on the user context, that's traditional collaborative recommendations, like collaborative filtering. What has my user done? What are they clicking on? What are they interacting with? What is their behavior? I don't need to know anything about the content or the domain to be able to find relevance. I can just use matrix factorization and collaborative filtering, and I can say these things are related because users think they're related. And that's if you think of those three circles isolated. But I think what we have to do in relevance and search and relevance is to look at the intersection of it. So if you take the content understanding and the user understanding, instead of document matching and recommendations, you get this notion of personalized search. This user is running this search, and when they say these words, this is what they mean. Or this user's in this location, and the meaning of their query changes based upon that location. So that's if you look at the intersection of those two. And if you look at the intersection of the content and the domain, that's where you end up with semantic search. Given these queries and this domain, the words have relationships to each other, the concepts have relationships to each other. And that's what most people focus on today, purely because that's what out-of-the-box embeddings are really good at doing. And so you get this sort of intersection between the content and the domain. And then, of course, what you ultimately want to do is intersect all of them together. And that's, to me, where you really get user intent, is when you combine understanding of the content, the user, and the domain. And so for me, whenever I'm working with clients and doing search work, I'm always trying to pull all of those strands together and really focus on, in this moment in time, for the content you have in your index, for your domain, and what you understand, and for this specific user or group of users, what does this mean and how can we best match the content? So that's my kind of general mental model for this. I don't know, Doug, if you want to elaborate.
Yeah, just to add to that, one thing I think about too is the level of spectrum of certainty, how confident you are that you know the intent. And often it's under, obviously, if you type Like a most common case is like you type a part number into a search engine, you know exactly what the user wants. It just show them that part number. And then it's a spectrum because sometimes people just come to the search and type a broad topic and they don't quite know what they want. And so a lot of the information need or the intent words can be used somewhat interchangeably, is unconscious or not even known by the user until they start trying stuff out. And we've all had an experience probably where we shop and we start shopping for a general category. And when we're interacting with the search results, we actually are like kind of learning what's possible at those broader searches. And then we're over time narrowing down to, oh, we actually want this specific thing. Like first, I just want televisions. And at that uncertain level, you're kind of focused. You kind of want to show them more diverse results than obviously you don't want to show them thousands of the same type of television. And then when you get farther and farther and the user gets more, they see more results and they kind of make more decisions about what they want, they have a lot more certainty about their information need, and they could probably write a full like paragraph about it. And if they were so wanted to, and then you get really, really specific, and your job is to like nail that specific target that they're looking for.
Yeah, it really clicked for me actually at Haystack. I was listening to Doug's talk when he talked about what should show up when a user searches for red shoes. And when you ask the question, it's like, well, obviously red shoes. And then he shows you like two pairs of red shoes. And it's like, wait, one is burgundy dress shoes. The other is kind of like tennis shoes that are red. And the question is, what should show up? And the answer is probably, it depends. And figuring out like where it depends and when it depends and why it depends is the fun part. So you guys touched on something. I had a question I was going to ask, which is, how do you evaluate your search? And you guys both mentioned using analytics or maybe click rate in a CTR platform. But imagine a more traditional search. How would you go about evaluating your search when you don't have that human labeled ground?
Yeah. So one thing that I found, I think about this a lot because I've been on the last several years, I've been on teams and helped lead teams and seen them evolve and made a lot of mistakes too. So one mistake that I see teams make a lot is to try to make it overcomplicated when they don't have really the resources to do that. So one thing I always warn people about with search, it's interesting because I think search and AI just have different problems here, but search teams can get sort of like over their skis and trying to model the perfect labeled data set when there are good 80% solutions out there. So I always encourage people to just start really simple. So first, don't start with a stop the world. We're going to spend 6 months in evaluation data, so that then we can spend then we can do the search work. You really have to build the airplane as you're flying it. And so I always encourage people like first think about some simple things that are effective are things like side-by-sides. So you can get a sense for, in a slightly quantitative sense, I like to call it a Pepsi Coke challenge because it's kind of like a blind side-by-side. And for those who don't remember, Pepsi Coke challenge was like a marketing gimmick where they put Pepsi and Coke in front of people and they didn't know what it was and they said which one they preferred. And if you just give people like two sets, like here's a query, here's a bunch of queries, which of these do you prefer? I find that to be sometimes more effective than like, I'm going to build the perfect evaluation, like judgment list evaluation set.
Yeah.
And I don't, because often building the perfect judgment list takes time. You really have to understand what's behind it. So is this a human label? Is this a click-based label? Okay, how are we dealing with all the biases? What if our labelers disagree? A lot of things like that. The other thing within that, so if you have sort of a good side-by-side system, sometimes what you really want to know is when you make a change, am I affecting the queries I expect to affect? And then within those queries, those are where you can really focus your like more side-by-side sort of evaluation. And you can at least know you want to avoid making changes to things you are sort of like, why that's weird. Why did that query change? And for example, if I'm working on like a query where like if the user mentions the brand of furniture to use or something like that, I know I can tell if I affected queries that mention brands, and I can tell if I left alone the other ones. Like that is a hugely important signal. And if I have that in place and I can do some side by side, and many teams have at least some teams, not all teams, have some general A/B testing infrastructure. That's usually a good start. And then what you want to do from that, if you're shipping changes within that, like I found, then you want to start to, okay, I need to debug why results are not coming back the way they are. Then I can layer on a bit of labeling judgment lists where I can start to get some maybe human evaluation, like from internal people, or some simple click metrics to say, like, at least flag when things are like, this is showing up a lot, but no one's clicking on it.
Yeah.
With all the biases, obviously, that you would want to keep in mind. And then all the way far down the spectrum, if you're training re-rankers and stuff, all the stuff I just talked about, you really have to have rock solid. So you really need to know, like, these labeled data is solid. I've dealt with all the biases, which we could go into because there's many biases in search evaluation. I've dealt with it sufficiently that I can trust that I can build a re-ranker that will rank results according to that training data. But I think most people just need to start simple and make some reasonable progress with some 80% solutions.
Yep. Yeah, I agree with all that. Doug is very much a pragmatist, which is like, don't do the hard thing. Start with the easy thing because that's where you get the early wins. And I completely agree. I think, like metrics wise, there's like NDCG and MRR and things like that, depending upon if you're trying to figure out like overall ranking of multiple relevant items, things like NDCG tend to work better. MRR, if you like, are just trying to find like the one best, and how high you can get in the list. So there's nuances with like what metrics you use, but the general, and then obviously precision and recall, I tend to like to collect them all and actually look at each of them and see how they're doing versus focusing on a single metric because they all tell different stories. But I do think in the general context of evals, for me, it's really important that I have a set list of queries that I always run, almost like a unit test, right? It's like every time I make a change, I want to run through these and want to see what changed. Like Doug was mentioning, like what are the side effects? If I fix this query, what other queries blow up? And so being able to see that you're making net improvements, and also when you break something or make it worse, what actually happened. And ideally, you can then dig in and figure out, some general like classifications of those types of errors. Like over and over, I'm seeing a type of error where I'm showing things in the wrong category, or where I'm, matching on the title correctly. And then you can deal with those as sort of individual problems. I mean, I think this maps over also, Thierry, I know you were mentioning agents and maybe wanted to talk about that some. When you start to deal with these, I'm going to call them not higher level, but, like abstract up a level from search, where you've got like an agent and you're generating prompts and you're trying to build a system that can respond to those. Often you've got like multi-step processes you're going through, right? And so what do you do then? How do you evaluate that? And I feel like one of the important things is you want to have the overall prompt coming in, and there's this like high level, like, did I get the right answer or not? And why? But also you want to have like trace level evaluations there. You want to know, like, at the first stage, what did I get? At the second stage, what did I get? And it's the same thing there. You can go overly complicated by trying to overanalyze every part of the system. But I like to look at it and say, where's the first place? Like, I didn't get the right answer, but let me go to the first stage that actually failed and then try to classify that error as, what went wrong. And then if you do that across 10 or 20 different prompts, 20 different queries coming in, you'll also be able to start to categorize the problems as, okay, over and over, I'm seeing this type of problem. And then you can really focus on what to solve. But if you don't collect the data on what queries are coming in, you don't collect the data on, what results you're getting and how they're working and how users are responding, it's really hard to do that in the abstract. It's hard to be a product manager or search engineer and just come up with a bunch of use cases that you think are probably what users are going to do. Because in the end, yeah, you might be a domain expert and you might be right 50, 60, 70% of the time, but you're going to miss a lot of things. So I think collecting data is the most important. And then having sort of a structured process around making sure when you make changes that you're clear on what's improving and what's not, so that you can dive in and target specific issues.
Yeah, users always break your QA, right? They'll start searching for things you didn't expect, and they'll get frustrated at results that you thought were perfect. And it's like, wait, what's going on here? I guess you thought red shoes meant something different.
Evals are so critical, yet they're often overlooked because they're not fun. Like nobody enjoys doing eval. I mean, some people. Most of us don't enjoy doing evals, but they're so important.
Oh, actually, I badly want to chime in on that one, because I've noticed that people now thought that LLMs kind of solved evals, because they were like, okay, finally, I don't have to think about it. I'm just going to dump it into my ChatGPT, whatever, and it's going to evaluate everything for me or do an evaluation data set for me. And as a person who worked in crowdsourcing before, I was a dev role in crowdsourcing, so I know how actually all of these search relevance evals are done. There is a lot to set up. And for example, UI is very much important, because you set up the wrong UI for evaluation, you will get the wrong output. So I think you probably already saw a lot of cases when people use LLMs for evaluation, and maybe you can share some experience what they do wrong, like how you shouldn't give the LLMs the task of evaluation.
I'll start with one quick thing, and I think Doug might have some more feedback on this one. A really bad way to do LLM-as-a-Judge or LLM-based evals is to ask the LLM, are these results relevant? Because you're completely outsourcing what the definition of relevant is to the LLM.
Yeah, who said that it knows what relevance is?
Right. And I've seen cases where people do that, where, oftentimes, not every, depending on the LLM will be very confident in its response that it gives you back. And I've seen cases where taking human evaluators and the LLM, you get almost inverse results. Like the LLM actually gives the opposite of what a human would say in many cases. In my experience, the best, yes, you can use LLMs to evaluate, but you have to be very specific on defining this is what relevance means. And like you can imagine a giant prompt that says, here's an example, this is relevant, this is not, this is why. And you just give lots of examples where you're basically defining a rubric, right? And the LLM can follow that rubric. That's really not a problem, but you have to be clear yourself on what is relevant and what is not. And at that point where you know exactly what is relevant and what is not, well, at that point you're doing relevance engineering, and you can just tell the system to do that. So I do think LLMs are incredibly useful for generating content. You can use them for evals, but the work of figuring out relevance, you still have to do, and you still have to give that to the LLM, at least currently with the current state of LLMs. That's been my experience thus far. I'm curious, Doug, what you think?
Yeah, my experience with this is like, it doesn't replace human evaluators. It replaces the probably extreme level of crowdsourced evaluators that we used to do, but you need some baseline of human evaluation or some evaluation. And then where LLM-as-a-Judge is really valuable is like in the tuning loop. Like I'm sitting at my laptop, I have search results. What often happens when I'm tuning with normal labeled judgments is, of course, I get results back that in my top 10 that don't have any labels, because maybe I made search better, or maybe I like upset the apple cart and like changed too much stuff. But I've changed like the recall entirely of my data set, and like now I'm getting novel results for most of my queries. And previously I would say, okay, well, let me try a bunch of hacks. Let me just ship it. Let me get it labeled before I send this out to an A/B test or whatever. If you have an LLM as a judge, you have something that can do the labeling in real time. This LLM as a judge is pretty good 90% of the time at reproducing these other labeling system I trust. That's one perspective. I've seen other people actually argue a different perspective, which is like, I want to use LLM as a judge to give like a completely novel and new perspective, which is totally valid. But for me, often when I'm working, I'm like, I was able to get hundreds of queries labeled 50 results each. Well, I can use that to see how good my LLM prompt is at like reproducing that evaluation. And if it gets to like 80 to 90% similar, that last 10% is often like either mistakes the humans make, or like, reasonable disagreements, then it can start to become part of just like my development workflow. And that's where it, like, to me, where it really is powerful. The other thing I think about LLM as a judge, and this is honestly true of any judge, is often people are better at giving a preference of like, I prefer, if you say, for the query red shoes, which of these results do you prefer? Which is more relevant? People will do a pretty good job of giving one preference. Whereas if you give them a scale of 1 to 4, they may just label both of them as 4, or they may start to like, they may make mistakes because you give them more degrees of freedom and they have to think harder. But sometimes a pairwise preference is like more information, but you have to do it. You have to like do a lot more of them, obviously, because you have, instead of like looking at a single item in isolation, now you're comparing everything to everything potentially. And of course, with humans, that pairwise preference gets like pretty tricky because you're asking your humans to do a lot of work. Maybe the Cartesian product more work. But if you're using LLMs, especially if you're having LLMs do simpler decisions, like which of these do you prefer, then you can sometimes use pairwise evaluation methods. And I sometimes think that's like, we're so used to in search this very pointwise system. I sometimes think we should, this pairwise way maybe should have a bit of a renaissance, just because we can automate a lot of the stuff now. We don't have to rely on humans to make a lot of like, okay, A versus B kind of decisions.
Yeah, I was actually working last night on a demo because OpenAI just released the open source model. And I was building an MMR, basically natural search with the MMR inside to just show people what the difference is between a legal search with and without. And I was literally using the two techniques you guys mentioned, right? I had it side by side, and then I would just change the diversity score. I would go back and look at the same query and be like, how'd it change? It's good to know that my technique, can't go wrong if you keep it simple, baby. Jenny, do you have a question?
Actually, I have a lot and none at the same time, because I am getting interested in the several topics that were passing by. Now, actually, let me return to one of the things that caught my attention a lot when we were speaking about it. At some point, Doug said that RAG people, I like the term RAG people, by the way. So our audience is mostly RAG people, I can imagine. And you were saying that there are troubles with getting the user intent inside the RAG, because basically there is no UI. There is this LLM that you're chatting with. And what do you think we're missing in RAG when it comes to the signals, which were usually before like clicks and stuff? Like, how can it be transferred to the RAG board? How can we try to use this part about the user intent, user wish in RAG? Maybe there is a way already, or we're yet to discover it.
And I'll just quickly add in, I'm curious as well as your thoughts on rewriting queries.
Yeah, I think it's interesting. I do think I think there's a missing opportunity, and there's a lot of prior art. It's not like a slam dunk, like everything, nothing's really a slam dunk. There's so much prior art, and it's pre-2022. I spent so much of my time, and I think Trey too, just like, how do we make sense of like clickstream data? And like, that is the root of how we're going to improve search. And that's really what ML in search is really all about. So there is like a lot of art that's there for people to tap into. But of course, when it comes to RAG systems and AI systems, it really depends on like the user interaction. So there are systems that are like more or less like chat. I would say like on one end of the spectrum, they're like chat-based search systems where you're still getting your grid of search results. You just happen to be chatting about them with an agent. Then maybe there's kind of an intermediate step where you kind of have like a system where like maybe informational system, like if you go to ChatGPT and you ask it to search the web for something and tell you about a topic, it will give you a sort of like, those citations and everything. And depending on where you are in that, like how you would use analytics to me is just dramatically different. I feel like obviously on the sort of chatting about search results side, we might have some hope if there's a grid of search results or the chat shows some search results of using the traditional click-based metrics. But then you have to, most of those assume that like 1,000 people are going to search for the same query in a week or something like that. And in that case, like you can aggregate that, you can see the patterns of how people are interacting with search results. To sort of aggregate a chat, you have to somehow you do have to rewrite it. You have to say here is the user's intent. They want this color thing, this item type. You have to really get it in kind of a structured way so that all the people that have a similar intent to that you can use their analytics. And then you may want to look at similar intents, not just the exact intent, because you may not see that exact intent all the time. There is this idea that's come up a lot too that's related of what's called a semantic cache. So if I have a query I don't know, Starship Troopers DVD, and then someone else comes along and searches for DVD for Starship Troopers. Semantically, if you look at embedding, they're almost exactly the same. And you would expect if you want to produce any structure for that, you could see that their similarities 0.97 and know that you've already computed one sort of structure, you can use the other one. But then you can also sort of use that as a way to hash to the same identifier. So that when users are interacting with search results, you might be able to sort of aggregate their click data together. So if you sort of think of them as the same thing. But yeah, it's an emerging field. And the citation thing is particularly interesting because it's known that almost no users are going to I will click through citations if I think they're actually suspicious or I'm not sure I trust the LLM. So it's almost a negative signal. But I don't know how you take signals about the content to then feed that back into was the search good. To me, that's a really tricky thing.
So I'll take the second question, Thierry, that you asked, which was about query rewriting. How do you feel? And I'm guessing the context there is, maybe can you expound on the question? I want to make sure I answer it like you're intending it.
Yeah. So obviously a technique that we've seen gain popularity is this idea that users aren't very good at writing their own prompts. So what if we set that prompt to a LLM and kind of massage it to go through? But of course that has some pros and cons. So I just wanted you to kind of explore the pros and cons of that approach.
That makes sense. So Doug's teaching a whole class on doing this. So I want to let him answer that in a second. But let me preface it with zooming out slightly, because one thing that I find time and time again when I talk to people in search is that we tend to be, in information retrieval, we tend to be really bad about coming up with names for things. And then sort of trying to put these classifications, and then we put things in those buckets. So I'll give you a good example, semantic search. Doug and I were doing semantic search before Word2Vec ever came out and people even knew what an embedding was, right? Semantic search literally just means search on meaning. So instead of searching for this particular piece of text, lexically, I'm searching on meaning. And there's lots of ways to do that, right? I can have classifiers. I can, do dynamic query expansion. In some ways, a synonyms list, if it's really robust, is another way to do semantic search. If I know this word always means these things, not necessarily contextually, but it's a way to do semantic search. So there's sort of sparse lexical ways to do semantic search, dense ways, but the marketing people in some of the search companies, in the last 5 to 8 years, decided they were going to brand search on dense embeddings as semantic search. And so now half of all the people I come across in information retrieval, when they say semantic search, they mean, doing some similarity metric on a dense embedding. And this is not what it means. And, we know that, but it's hard to rewind somebody to say, no, there's lots of techniques. Another example is hybrid search. A lot of people, when you say hybrid search, they're like, oh yeah, I'm running a lexical search and I'm running a dense vector search, and then I'm combining them. Well, there's lots of different query modalities, you could have hundreds of different ways to query and combine them or merge them or even do them as part of the same query. So that's a whole another topic, not for this question. But going back to the question of query rewriting. So in the early 2010s, mid 2010s. So I was doing a bunch of work when I was at Career Builder on something we called semantic knowledge graphs. And we published a research paper on it. But high level, imagine, we know what a language model is. We know what a large language model is, but we've had language models before that. We've had language models that were just for doing autocomplete or spelling correction, things you just build based upon your data. Your index, and let's talk about an inverted index for a second, is a language model. You're literally taking all of the text in all of your documents, you're breaking it apart, you're creating an index, and you're linking documents together. So in most search engines, you've got a postings list, which is your inverted index, where you're taking keywords and mapping them to sets of documents. And then in most search engines, you also have a forward index, which is matching document IDs to sets of terms. And so if you've got the ability to take an individual term and find a set of documents and take each of those documents and find sets of terms, you basically have a graph. You have the ability to traverse from terms to sets of documents to terms to sets of documents, as many dimensions across as many fields as you want. And if you have some way to rank those edges that you're creating, then based upon semantic similarity, then that's what we call a semantic knowledge graph. So going back all the way to like the mid 2010s, I was doing things like, taking in keyword queries, going and checking the index and finding the most semantically related other terms from my inverted index and bringing those back for either query expansion or for like filtering. For example, one technique is, somebody types in the word driver. Well, that could mean a type of golf club. That could mean like an Uber driver. That could mean like a printer driver. But what you can do is you can say, hey, I want to take driver. I want to then find the most semantically related category. And I might get DevOps and I might get, transportation or travel or something. And then within that category, find the most semantically related words. So in the category of travel, as it relates to driver, I get Uber and Lyft and bus and car. And in the category of DevOps related to driver, I get things like Docker and, whatever things, tech terms. But what that allows you to do is create these dynamic categorizations where you can then either get diverse results from different categories or say, no, based upon the user context, the domain context, and the content context, I'm going to pick one of these meanings and rewrite the query to be specifically that meaning. But all of these things you can do, semantic search, query expansion, query rewriting, query classification, you can do all of these things just using a sparse inverted index and just stats within that index. Or you can flip the script and you can use embeddings and you can do similar types of techniques. But I'm a huge fan of query rewriting because if you know your domain and your use case, you can represent to whatever engine you're querying a much more specific and accurate representation of what the user likely means based upon taking all this context in versus just, I don't know, throw it to the LLM and see if it can figure it out. Now, you can do that. And if you tell the LLM what you mean, it can also do the rewriting. Doug may want to talk more about that because he's been working a lot there. But I would just say in general, the better you can represent your query using all of the available context and data to your engine, the better your results you're going to get.
Oh, sorry to cut you off at the end there. But the example I think of is like the viewport versus someone saying, hey, I want my hero to take up the entire screen. Just being able to have that language to talk with the model all of a sudden makes you a better programmer because you can tell the machine, hey, I want it to cover the viewport. So Doug, go ahead, please.
Yeah, there's a reason you probably want to have structured and even lexical data in your system and why hybrid search works so well. One thing is there's this concept that you may have talked about on the podcast already called embedding collapse. And what embedding collapse is if these embedding models are trained on like the world of data and you are probably your niche. Let's say you work in finance. Well, everything in your corpus is going to be like 0.1 cosine similarity from everything else because you're like in this corner of the universe. And this is a very common problem. So if you search for something, the similarities of my query to other content is really tight, small. And so you notice these things like you're surprised often how close things are, in part because like sometimes you can find a good model trained on like just finance data and that's great. But sometimes you can't. And so to fine tune, it's often easier, I think, to fine tune some of these more structured approaches because you literally can just turn some knobs and dials in the search engine than fine tuning an embedding model. Like fine tuning an embedding model is its own layer of complexity and massive project. Going in and saying like, I want embedding similarity on this generally good embedding model that mostly works fine, except for these specific cases where I need to like, maybe I know the user's intent, like the user is like searching for an item by name, or I know that they're kind of searching within this category of stuff. Like that's a really good reason to structure queries into some understood context before and filter before you do embedding search, because that really can help narrow things down without having to go down the like, I have to like take out PyTorch, how do a good training set for my data, and somehow fine tune an embedding model for my data, which is really hard and sometimes can lead to all kinds of unexpected consequences. So I do think like in some ways, and not to mention if you want to incorporate any kind of domain rules or like business rules into your ranking, that's kind of why I think a lot of structured interpretations of queries like in classic lexical search techniques still persist. But I also find that embedding, we used to probably do something where our sort of default retrieval would be maybe BM25 scored. I often see more default retrieval is often like an embedding first pass retrieval, and then we are tweaking and tuning within that. So yeah, that kind of like hybrid search is really complicated, but like doing filtered hybrid search where you understand the structure of the query is extremely powerful.
Very, very cool. I have a question for both of you, and then I'm going to pass it back to Jenny, and then we'll be close to wrapping up. What is your favorite part of the book, each of you, if you don't mind sharing?
Let me think. I don't know, Doug, do you want to go first?
I of course am biased by things that I wrote, but one thing that I am excited about is this idea in traditional search systems, one challenge with clickstream data is you have to deal with the explore exploit problem. So presentation bias is basically like users are only going to click on what the current search system shows you. And so if you're going to train a model, well, you're just training a re-ranking model to shuffle around stuff in your current top 10. If your results are already terrible, maybe you have a preference for one result or another, but it's still just like for that query, it's a bit of rearranging the deck chairs in the Titanic situation. So what I get excited about is like, if you look at the results you're showing for a query, are there types of search results you haven't explored? By types of search results, it's sort of features of queries and documents that are like not represented in your training set that you want to explicitly select for when you're showing users results, so that you can at least gather information on whether this is a good area for exploration for your model. And there's a whole field of active learning that kind of feeds into reinforcement learning to do this, where you're kind of like, where are the gaps in my data? Where are the opportunities for exploration, and how should I do that? But I want to add to that. I think one thing I want to shout out is the end of the book in general we wrote the book before and then after ChatGPT happened. So that made life really hard. So even though nothing stops being relevant in the space of information retrieval really, but the focus of what people cared about when they heard AI powered really dramatically shifted. And so especially Trey and Max, our co-author, just that end part of the book where we had to like believe and speak to and talk about the embeddings and the cross encoders and LLMs and everything was like just really, really tricky to do. And I think Trey is in particular chasing after a field that was like moving very fast relative to our ability to keep up.
Yeah, I think we timed it quite well because there were a lot of things that were not settled that kind of got settled right before we were able to write and get it out. But yeah, everything from, crossing, like there's a lot there in terms of, hybrid search, multimodal search, cross encoders, a whole bunch of stuff that just had to be in the book that, even 6 months prior didn't necessarily have to be, but it needed to be there. And the kind of line we had to draw was really getting into things like late interaction. It's like I really wanted to spend time on late interaction in the book, but just due to the size of the book and the timelines, we had to kind of draw the line there. It's mentioned, but it's not demonstrated, if that makes sense. Whereas if it continued, I would, definitely spend a lot more time there. But yeah, it's like I think the content will be somewhat evergreen for many years to come. And there's obviously new techniques, but I think it like hit it like just the right time given the industry's kind of development. So chapter 4 was fun for me because a lot of people know it should be done, but they don't know how to do it. And so it's very prescriptive. Here's exactly what you need to collect and why. Even like a schema and a structure. But then that plus the rest of the book, about a third of the book is on these models that use user behavior signals, whether it's signals boosting, learning to rank, personalized search, all of those chapters they're not novel in the sense that they've never been done before, but they're new to a lot of people because they're the things people have never gotten to. So I really like being able to do that. Like even in the personalized search chapter, there's a bunch of things in there where we're taking individual user signals and we're clustering them and we're generating recommendations, but we're also, with matrix factorization, generating behavioral based embeddings that are, there are embeddings and they're using all these dimensions, but they're learned from the user behavior as opposed to being generated from a text-based LLM. So there's things like that most people just have never done, but they're the same. They're all the same problem. It's just which data you're connecting together and how you're doing it. So be able to like inject a little bit of what will seem to readers as novelty, even though it's really just, doing the same thing with different data in different ways.
Yeah, like flattening out the GraphQL data and then building a two-tower model that takes like metric learning into consideration and all that. And also want to shout out Doug is teaching a course. We'll have the link to both the book and the course in the comments. Doug, you want to just once again give people an idea of what they'll find in your course, and then Jenny, take it away.
Yeah, sure. So if you go to maven.com/softwaredoug, I'm just teaching a class it's called Cheat at Search with LLMs. Really about, I use the term cheat at search because I think we can make this a lot less complicated. We can use LLMs for a lot of structured query and content understanding and other things as well. I talk about LLM-as-a-Judge. So if you're interested in improving search relevance for regular search or RAG or whatever use cases, check it out. And there's an early bird discount, SearchyBird, Searchybird, until August 15th. So definitely check it out.
Awesome.
And for the book, you can go to aipoweredsearch.com to grab a copy. There's also there's a lot on the site. So there's like blog posts. We've kind of got a who's who in search and AI and partners and things, but there's also a community there. So if you want to join, there's like 800 search and IR people in there that we're going to be ramping up there a lot soon. So if you want to join that as well, there's a lot of opportunities to continue to, beyond just the book, to continue to learn and interact in those books.
I mean, one of the really cool things about the search community is just how willing everyone is to like share information. I think that's like really cool because Haystack was a little intimidating for me as kind of the newbie in search, and you're interacting with all these people who are like, yeah, I invented TF-IDF, and it's like, whoa. So being able to just learn from people has been really fun.
Since we were mentioned search community, we have yet another Haystack approaching, this time European one in September. And they're actually going to be on the same week as Quadrant's Vector Space Day, because we finally decided to gather all of us in one place. Will you believe it? I saw Thierry only once in my lifetime, and that's going to be the second one. And I really love Haystack because I think it's one of the best conferences about search, as I like Berlin buzzwords. So the question is, what are you expecting to see at this Haystack? What's the next big thing in search that you're willing to hear about? What would be super interesting for you to find out there? That is a little bit maybe a silly question, but it's for everybody. Thierry, it's also for you.
I'll actually start and let Doug and Trey gather their answers. I just saw the paper from Anthropic where they were talking about the good and evil vectors. And I think that's going to be a really interesting way to start thinking about search. Because I'm assuming that if we have these good and evil vectors, there's probably other interesting vectors that we can find if we keep searching and digging, and also kind of realizing, hey, there's a lot more happening with these numbers than we realized at first. So that's what I'm excited about, is people digging into that.
Yeah, one thing I'm excited about, I think we'll just see, I feel like the market has gone through a phase of wanting to build Chat GPT for X. I feel like that bubble is maybe popping or is cresting. I'll be interested. Where I think things are interesting with LLMs more and more is just the quote unquote, it means so many things to different people, but agentic space of like doing actual work, and like how does search play in with that? Because often you have tools that you want the agents to use to go and find things, and all of those tools may have relevance that works differently, and there's probably ergonomics and expectations around search tool APIs and how they should rank results depending on how you're describing them to an agent. Like, here's how you search for a thing by name and title, and here's how you search for things semantically. Like, I feel like there's some tool usage design for LLMs that is just an untapped field that
Mhm.
would be really interesting for maybe will come up in Haystack EU, but I feel like will be more and more the focus in the next year or so.
Well, on that note, thank you, Trey. Thank you, Doug. Once again, these are the authors, along with, I believe it's Max Irwin of AI Powered Search. You can find that at aipoweredsearch.com. And Doug is also teaching a course on Maven. So if you go on Maven and you search for Doug Turnbull, or
You can search for Cheat at Search, Doug Turnbull, and I have no idea if their search is good. Hopefully,
let's find out.
yeah.
If you need help with your search, let us know. But yeah, you can find that, and then I know your website as well, Software Doug. Love the branding and the stickers. Thank you, Jenny. Do you have anything you want to close us out on?
I just want to tell also thank you for hosting this vector search talk. That was super fun. Honestly, just enjoyed chatting. It's so hard to finish because I have so much more to discuss, but I mean, at some point we have to, right?
Yeah, exactly. Hey, maybe we can do a round 2 in Berlin, right?
Absolutely. Yeah, I really hope to see all of us.
Thanks so much for hosting us.
Thank you for coming by. Thanks everyone for watching this episode of Vector Space Talk. You can find Trey and Doug online. You can find me and Jenny online. If you want to check out Quadrant, go to quadrant.com. Check us out on Discord. Say hello. Woohoo!